All right. Good morning, Jamie, or good afternoon.
Afternoon, sir.
How are you doing?
I'm all right.
All right. Good to hear. Good to hear. All right. So, I would have sent you just a while ago PDF. The PDF won't have normal distribution in it because I didn't get to summarize the normal distribution part of the note as yet. So I got to summarize the binomial and probability distribution table. So I don't want to say later today, so look for the normal distribution notes, maybe sometime tomorrow. All right. Yeah, so the normal distribution part, I'll summarize it definitely by tomorrow. Now, I also just a while ago sent you some documents for conditional probability and tree diagram. Now, it's already in the notes are already in the probability notes that I would have sent you. But again, I don't have that probability notes document, so you don't see it here because as I said, my applied and into math, they were deleted. So I don't download it back out of my drivers yet, but it's okay. We can work without it for today. All right. So we're gonna start with probability then. Or I'll let you choose. Which one you want us to start with? Finishing off probability or the normal distribution? Doesn't matter how we start. Which one do you prefer?
You can finish probability.
All right, let's finish probability. All right, nice. So we're gonna start with probability. Now, so far on the probability, just to refresh our memory, we were looking at laws of probability. So to refresh our memory first is defining the probability of any event occurring E. We said it's the number of times event E occurs divided by the total possibility. That's the definition of probability. After we define probability, the first one that we looked at, the second thing, we then went on to look at number 2. We looked at the probability of what we call exclusive events. The probability, oh no, we went on to union first. We looked at the probability of A union B, and we said that is the probability of A plus the probability of B minus the probability of A intersect B. That's the union law. So that's the second thing that we looked at, the union law. Then the third thing we looked at was the complement law. The third one, the complement law, where we said that the probability of A complement is equal to 1 minus the probability of A. That's a complement law. We then went on to talk about independent, mutually exclusive, and exhaustive events. Now, let's start back with mutually exclusive. Mutually exclusive mean the two events never intersect. They never can occur simultaneously. So A and B cannot occur at the same time. In other words, we summarize it and say that the probability of A intersect B is equal to 0 when they're mutually exclusive. And then that would lead to giving us the probability of A union B would be the probability of A plus the probability of B minus the intersection of 0. And so it's just the probability of A plus the probability of B for mutually exclusive events. Then we went on to independent events. And we said that two events are independent. So A and B are independent if the probability of A intersect B is equal to the probability of A times the probability of B. In other words, the probability of A union B is going to be the probability of A plus the probability of B minus the probability of A times the probability of B. So by combining the union law and what we know about independence, we'll get this new union law. Because we know right here would have been the probability of A intersect B, but if it's independent, then A intersect B would have been given by that formula. So those are all we've done in probability. The last time we were looking at probability, right? We did all of that, right?
Can't remember exactly, but I think so, yeah.
I remember. All right, no problem, no problem. All right, when you get the chance to review, definitely. So we covered all of this. And so now we will be looking at conditional probability. Now, conditional probability, as the word suggests, condition. There is going to be, oops. Oh, this was the notes that I just sent, summarizing everything. I don't need this document open. What is this? Binomial. All right, now that we're looking at conditional probability, it's really one formula you need to know, Jamie. One dege formula, conditional probability. As the word suggests, Jamie, it's condition. It's very condition-based. Conditional probability is the probability an event occurs given that another event has already occurred. All right, so conditional probability, this is the possibility of an event occurring given another event had already occurred. All right, that's conditional probability. It's based on if another event had already occurred. For example, look at this. This would never be the same to probability. Let's say I ask you, let's say there's a class of 40 students, right? There's a class of 40 students. Let's say, well, I'll use, for example, how many students are in your Intimath class?
11.
11? All right, so there are 11 students doing integrated mathematics. And I say, what is the probability? So there are 11 students. I say, what is the probability that Jamie comes first in his Intimath class? What would be the probability of you coming first in the Intimath class?
Probably 0.9.
0.9, very good. 1 out of 11. Now look at this now, Jamie. What if I say, let's say, Jamie, all right, what if I say given Jamie is in the top 3 Inti math students, what is the probability, Jamie? What is the probability Jamie places first? What would that be?
Be a third.
Very good, 1/3. Notice we get 2 different answers. And the same thing I asked for, you know, what the probability Jamie come first? But I throw in a condition here. You realize that condition I throw in change your whole answer. So this is where we're going to look at what we call the conditional probability formula. So this is the conditional probability formula. So the probability of A/B it's equal to the probability of A intersect B over the probability of B. Now you're seeing some slash and whole heap or something. Let's talk about what this slash is. Now, in other words, the slash right here means given, right? That means given. So this is saying the probability of A given B. And that's equal to the probability of A intersect B over the probability of B. So when we're doing conditional probability, the first thing we need to identify is what is given, the condition given. That's going to go to the right side in the bracket after the slash. And then the A is what you're going to be trying to find, the probability of A given B. For example, looking back at the example we just did, you got the 1/3, which is correct. So what we were trying to find is the probability Jamie come first. So let's put J1 for Jamie come first, given Jamie in top 3. So that we're saying it's equal to now the probability that Jamie comes first and Jamie in top 3. And then we divide it by the probability of B, which is the probability of Jamie in top 3. That's what we actually did to get the 1/3. So now, of course, the probability of Jamie coming first and being in the top 3, right? As we already said, that would be 1. And the probability of Jamie being in the top 3, well, there are just 3 students. And that's how we get the 1/3 utilizing this formula. All right, I can show you the full expansion where we can put the 1/11 and the 3/11 and what cancel out to end up with 1/3. Don't need to show all of that, but I'm just showing you the formula that we'd actually use to work that question out. So let's see how we're going to apply this one formula that we need to know to many different questions, because of course, they'll change the style of questions. So let's do the first one together then. Of course, after we do the first one, oh yes, I'm glad I put in the table one here. After we do the first one together, then you're gonna, of course, do the rest. So this says Andrea is a very good student. The probability she studies and passes her math test is 17 out of 20. If the probability that Andrea studies is 15 out of 16, what is the probability she passes her math test given that she has studied? So as I said, we're always looking for what is our A, what is our B. So first thing they told us is that the probability she studies and passes her math test is 17 out of 20. Let's represent that figuratively. The probability she studies, let's use S to represent she studies, and that keyword and, we'll put the intersection, and passes her math test. So let's put MP, meaning pass our math test. They told us that is equal to 17 out of 20. Then they say if the probability that Andrea studies is 15 out of 16, so the probability Andrea studies is 15 out of 16. What this question want now is, what is the probability she passes her math test? So the probability she pass her math test given that she had studied. So this is where we use the formula now. It's the probability of A given B. It's equal to the probability of A intersect B. So it would be she passed her math test and she did study divided by the probability that she did study. In that case, it would be probability she pass her math test and study was 17 out of 20 divided by the probability that she studied, which is 15 out of 16. So that's 0.85, well, 0.85 over, well, let's just put all of that in the calculator. Put that in the calculator for me, Jamie. That's too much to work out here.
But 0.91.
0.91?
Yes.
0.91. So in other words, there is a 91% chance she will pass her math test given she studies. That's very good. That means that there's a 9% chance you failed even if you study. But that means basically if you study, you're guaranteed to pass. 91%, very good. So Andrea should always study. And that's one way they can ask you this question. So of course, now I'm handing straight over to you. So you can open this exact document and you can write on it. You can open it in Microsoft Edge. The second question is yours. All right, yeah, question 2. Probability that Johnny smokes. Very good so far. Good. All right, always write out back now what is 0.89. What is that representing? Very good. If she smokes, very good. Nice. Question 3. Very good. Very good. Good. Very good, very good. Next one. Is that a R or is that a B beside the W?
So B.
Is that B? Okay, okay, it's a B. So why have W there then? I don't understand why the W is there. You want to find the probability it's blue, given that it's not white. Yeah, so it can be blue or red. Yeah, that's better. All right, what does BW? BW is blue and white, right? For blue and
Okay.
white, I want you to put an intersection sign in between it. All right? Yeah,
Alright.
when you're saying not red, you want them to say it can be blue and white, or you want to use a union sign. Either is fine. I just want them to know though that it's BW would mean blue times white. So I want them to see that you're saying it's just not white. So it can be blue or it can be white.
So for or I would use intersection.
Or use union, sorry, use union.
Alright.
Yeah. Very good so far. Very good.
I don't remember how to work this out though.
All right, no problem. That's where your bracket is critical. Put your bracket around B union red. Very good. Now, I want you to scroll up on like a different, go up to the first page. It's a clear page. So I want you to look at this. So for example, look at this. 4 times, write down 4 times in bracket 3 plus 2. How do you work that out using distributive property? It's, yeah, write it out. 4 times 3, yeah. No, 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 I want you to show the whole thing. 4 times 3 plus what? 4 times 2. Very good. So look at this now. See the intersection and the union as times and plus. So write down back the B intersect in bracket B union R. Expand that for me now using distributive law. Good. Now B intersect B is just B, don't it?
Yes, sir.
And then the B intersect, so B intersect B or B intersect B or B intersect R. But look at this, you can't draw blue and red at the same time, don't it?
No, sir.
So that part is 0. So all of this is just working out to just be the probability of being blue. See it? So getting blue and blue union red is just blue. That's all we're saying. So now you can finish the question. So we have to look out for stuff like that. Good. Yep, 3/8. Nice. 0.375. Second part. Right, now this expansion is a reminder of when you'd expand like A plus B in bracket times another bracket C plus D. How do you work out those? And put a bracket around the A plus B. Yeah. So this is an example of that expansion. Yep, 4 of them, 4 terms. Now look how it work out perfect. Because we know we can't get blue and red, white and blue, or white and red at the same time. So all of that work out to just be blue and blue, and blue and blue is just blue. Good. Yeah. Wait, this should have been 7 over 12 over 8 over 12, the second one. Go back up to the expansion because it should have been 7 over 12, blue or white. Blue or white. Oh yeah, here it is, or, blue or white. Yeah, the final answer should have been blue or white. Yeah, this expansion is good. Yeah, but here it is now. Because we were looking at the or with blue or white, we know blue and red is 0. The white and red is 0, but you see the part with blue and white, we typically don't necessarily want to expand the blue or white. Because we know the or mean it can be we're choosing from blue only or white. So we add up the blue and we add up the white, and that gives us the total being blue or white. All right, it should have been 7 over 12. Yeah, so the final answer should just be blue or white, or not intersect, blue or white. Yeah. So then when you go back down now, right here, you're gonna work out to just be blue or white over that there. Yeah. And the 12s cancel, 0.875. Yep. All right, question 5. From 10 to 50, there's 40 numbers. Are you sure?
Even numbers, would it be 16?
Repeat.
The even numbers from 10 to
All right,
50.
you see, for a question like this, I would prefer if you list it out then in a set. So if you go back to C-sec, you can use the even number. So put E with an open set bracket and write them out. Nothing is wrong with writing them out. So they will give questions like this, which you're gonna see. So write out your even set. You have enough space to do it there. Yeah, that's right. Oh, no, not draw a set. No, not draw a set. You can just write it out in set notation form. Yeah, so E equal, if you want to use E for even, and write out all the even numbers from 10 to 50. Write them out. Nothing is wrong to write them out. Good. Now add up how many even numbers that is. All right, now don't write equal 21, write N in bracket E equal 21. So N in bracket E, that means the number of elements in set E, yeah, N in bracket E is 21, not E. E is the set. Good. Now, what else you need from this question? You need numbers greater than 40. So write out a set of numbers greater than 40. Use a letter to represent that, greater than 40. That's 9, 10. Good. Now you can actually go ahead and start part A using the conditional probability formula. Realize we don't have the set E intersect F. So write down the set E intersect F now. You can do it on the same page, man. It's no problem. Yeah. Very good. 5 out of the total. 5 out of 40. Very good. That's correct. Now part B now. Very good. Very good. Next one. Mm-hmm. Good so far. But you're gonna work out D intersect E complement. Oh no, I don't think I showed you this law. All right, so I want you to write this down. This is a key law that would have came from substituting. So I don't know if you want to write it on a fresh page or maybe down at the bottom down. Yeah, on the question 7. So this is a law you need to know. The probability of A is equal to the probability of A intersect B plus the probability of A intersect B complement. I don't think I showed you that last. So I want you to see why this is so. Go to the white screen. You're going to come back and finish this question, but I really want you to see why this is so. So draw a set for me. Draw like a set, two sets, A and B, and the intersect. All right, now I want you to shade A intersect B for me. Now shade in another portion with a different color, A intersect B complement. A intersect B complement. Intersect, not the union. Good. Notice that A intersect B complement. No, don't shade inside B. No, wouldn't shade inside B. Would just be pretty much A intersect B
Oh, B
complement is,
complement. Okay.
yeah, A intersect B complement. Notice that A intersect B complement is A only. Then you add the intersection. Notice that together, both of them give you set A, right?
Yes, sir.
So I didn't show you that law. My sincere apologies. It should be in the notes, so I'm going to have to tweak that. So that formula should be there. All right, so now you can apply that to this question. I don't know how I left it out of the notes, but yeah, that should have been there. Very good, very good, very good. Very good. Part B, Very good so far. Very good. 1/6. That's correct. Very good. Very good. That's correct. Now, this right here, so this last question, this is a table question now. So sometime, not all the time, they're going to give you probability that is straightforward. Sometimes you're going to get probability that you have to use a table and answer the question, right? So you're still using the formulas that we learned, but now you're using the formulas in a table. All right, so go ahead and do these here. You're good so far. Yeah, what's the intersection? Can you get an A and a B at the same time?
That's right.
Yeah, so that's 0. Good. Can't get A and B on the test. By the way, if I were to ask you then, what type of events then are A and B? What do you tell me?
They're mutually exclusive.
Very good. They're mutually exclusive events. We cannot get A and B at the same time. All right, now put back at the front probability of A or B. Yeah, don't throw it away. Yeah, good. That's correct. No, very good. Part B. All right, now this is saying, let me see, probability of being, what is the probability an A student is male? So you look at the total, very good, yeah. Total male students that get A's out of the total A's. Very good. Definition of probability. Very good. Very good. Part C now.
But what do they define a passing grade as?
Oh, okay. Now, in schools, typically we define passing grades as A, B, and C. So A, B, and C. All right. Very good. Seeing the given sign is good. Very good. Very good. Very good. 14 out of 53. Now finish it off.
Everything I answer greater than one.
All right, wait. Male and failing. Let me look back. Male and failing over the probability of failing. How many persons fail in total? Failing is 25 over 100. Quarter is good. All right, male and failing. That's 14 males failed out of 53. What is the probability of a male student? What is the probability of a male student given that they failed?
Might be 14 out of 25, as in who were male out of who was failing.
What is the probability of a male student? All right, the wording here is bland. What is the probability of a male student given that they fail? Given comes after that they failed. Let me see, you wrote down the fail part. Probability of being male, given that they fail, it's the probability of male and failing, divided by the probability of failing, student in general failing. So male and failing is how many males failed. Wait, I'm just going back to the table. So that formula is good there. Let me go back to the table now. Males and failing. You want to use the formula probability of male plus the probability of fail minus the union. That give you the intersection, but still would work out to be the same. So males failing is 11 males fail and 3. That's 14. That's 14 out of 53. Divided by total that failed. Males and failing is definitely 14 out of 53. Male and failing, 14 out of 53. Yeah, just leave that one. Go to E. Just put an asterisk beside it because it has to be 14 out of 53. There's nothing wrong with the computation. Male and failing is 14 out of 53. All right, go back around now. I see the error. I see the error. My apologies. Go back to the next page. Here it is. The probability of male and failing. Male and failing is 14 out of 100. Yeah. Yep. That's it now. All right, go back around now. So that's it. Very good, very good, very good. That's correct. All right, very good. So how do you find conditional probability?
It's okay.
It's okay, good. So remember to write down the additional formula for me in your notebook. Remember the probability of A is equal to the probability of A intersect B plus the probability of A intersect B complement. Gonna have to re-edit the probability note to drop that one in, but just write it down in the meantime, all right?
Yes, sir.
All right. All right, so now that you got that down, all right, nice. So we finished conditional probability. So we're just ticking off. Let's tick off, right? So we know the addition and multiplication. Look at mutual, and we look at independent. We look at mutually exclusive, exhaustive. We did cover exhaustive. All right, dependent just mean it's not independent. We look at conditional probability, and we look at all forms of it with tables as you saw. And we did other conditional probability because they will ask you other conditional probability. They can ask you from a table, or they can ask you to do it with pure calculation. So just to skip around and show you like specimens, because as I said, we don't have enough integrated math past papers to only work with past papers. There's only been 5 papers, 5 paper 2. So we have to look at the specimen as well. So a conditional probability, did they ask any in the multiple choice? Here's a conditional given. So we looked at worded problems. That was the first type of conditional probability we look at. How many groups of blah, blah, blah given? Conditional probability from a table, we just look at that. We look at expected value and probability distribution table on Thursday, so we can cover these easily now. Nice. And then the paper 2, did they give any conditional? Probably not, because they have so much to test. I just wanted to see an idea of how they ask it. So they ask least, nope. Many groups of 5, combinations. We're going to finish combinations on Thursday. All right, bar chart, pie chart, box plot, binomial, you did that, and normal, linear regression, normal distribution. All right, they didn't ask any more conditional probability. Only 2 conditional came on the multiple choice. All right, now this one is also on the syllabus, the tree diagram, but they've never given a tree diagram question as yet. But it's still on the syllabus, so we're gonna do it. So they haven't given it as yet. We don't know what they're waiting on. So we are right here, tree diagram with and without replacement. They're yet to give a tree diagram for us to do, but we don't know. We don't know. Maybe this is the year. So sorry about that with the screen sharing pause. So let's go. Now, what is a tree diagram? A tree diagram is just a diagram that we're going to use to represent information given. That's all is a tree diagram. Tree diagram is just a diagram that we're going to use to represent information given. And the best way to do it is with an example. So for example, right here, it says a bag contains 3 blue ball and 5 white ball. Lamario picks up a ball at random from the bag, replaces it back in the bag. He mixes the balls in the bag and then picks another. Construct a tree diagram. All we're doing is simulating what happens. So I don't know why that keep happening, but let's go. So all we're going to do now is start with what happens. First thing we notice is that Lamaria have a bag. So we're going to use a dot to represent the bag. This is the bag. Then what did they tell us happened? the bag contains 3 blue and 5 white. So we're going to draw lines to represent. These are what we call branches to represent the different possibilities. So from the bag, you can either get a white or you can get a blue. Now, the total balls in the bag, once you add them, the 3 and the 5 give us 8. So the chance of getting a white ball is 5 out of 8, and the chance of getting a blue ball is 3 out of 8. So that's the first, that's what we call the first draw. So on the first draw, that is what can happen. Cool? That makes sense?
Yes, sir.
Now, after you do the first draw, they told us that Lamaria then put back the ball in the bag. Notice him put back the ball in the bag. So if you put back the ball in the bag, there's still 8 balls in the bag. So now there are 8 balls in the bag. So now we need to look at what happened on the second draw. So on the second draw now, given that it can be 2 possibilities. It can be that him draw the white first and then make him second draw, or it can be that him draw from the blue first, then make him second draw. So here we're just gonna write on white again and blue, then white again and blue. Because him replace back the ball that him draw back into the bag, there's still 8 balls in the bag. Chance of getting a white remains 5 over 8. Chance of getting a blue, 3 over 8. Chance of getting a white, 5 over 8. Chance of getting a blue, 3 over 8. That's a tree diagram. That's all is a tree diagram. And this is to represent the second draw. You're probably wondering, why does the second draw have more branches? It have more branches because there are many cases. It couldn't get a white ball first, then draw a white ball second. Could draw white then white, or him could draw white then blue, or him could draw blue then white, or blue then blue. So that's why the second draw you see 4 branches. Make sense?
Yes, sir.
All right, so now we can go ahead and tackle these easy questions that they're gonna ask to follow. So now the next part says, calculate the probability that Lamaria picks up 2 blue balls. So to get 2 blue balls would mean that you need to get a blue on the first attempt and a blue on the second attempt. So a probability of getting blue and blue mean we'll get blue first, they will come get the next blue. So in other words, using the tree diagram, it would be 3 over 8 times 3 over 8, which you know is 9 out of 20, well, 9 out of 64. 9 over 64, that's a probability of getting blue then blue. Now part C says, calculate the probability a blue ball is on the second draw. Now, for part C, if the blue ball is on the second draw, we don't care what's on the first draw. Probability of blue on second. So as long as blue's on the second, we can get a white first, then a blue. Or, so put plus, or we can get a blue, then a blue. Make sense?
Yes, sir.
So white, then blue will go here to here. That's white, then blue. So white, then blue would be 5 over 8 times 3 over 8. Plus, we already know the probability of getting blue, then blue. 9 out of 64. So that works out to be 5, 3 is 15. So that's 15 plus 9 over 64, which we can say is 24 over 64. Then the last one now is a conditional probability. It says a white ball on the second draw, given that he draws a white ball on his first draw. So they're asking us to find the probability of getting a white on the first draw, given that white on the second draw, double 2 to represent second draw, given that he got white on the first draw. So that will be equal to, using conditional probability formula, it's white on the second draw and getting a white on the first draw divided by the probability of getting white on the first draw. Now getting a white on the first and a white on the second, that's just the probability of white, getting two whites, over the probability of getting white on the first draw, meaning it doesn't matter what we get on the second draw. So it's just white and maybe blue plus white and white. Then we're going to work that out. So that would be now white and white is 5/8 times 5/8 divided by white then blue is 5/8 times 3/8 plus 5/8 times 5/8. 5 times 5 is 25, so that's 25/64 divided by 5, 3 is 15, so that's 15 plus 5, 5 is 25/64, which works out to be, the 64s will cancel, so we'll just get 25/40. That would be the answer, 25/40. Pull it this one?
Yes, sir.
All right, nice. So with that being said now, let me see what I save this as so you can take over. I save this one as probability tree diagram. So probability tree diagram, I save this document as so you can share your screen now. You're gonna do the 2 tree diagram questions for me.
I'm not sure if you sent this one.
Oh, you're not sure, you're not seeing it? Let me see. Tree diagram. I didn't send it. Tree diagram, tree diagram, tree diagram. Oh yeah, I did send it. I sent it as a PowerPoint. I sent it as a PowerPoint. Oh, but why does it have the writing on it? Do you see it?
Yes, sir. The questions are already done.
Yeah, so that's why I'm resending you over now. Don't worry, I'm gonna send you the PDF. So don't look at the PowerPoint as yet. PowerPoint, yeah, let me send tree diagram. I'm trying to find the PDF. Tree diagram. Where is it? Tree diagram. All right, I find it. So I sent you the wrong one. That is here now. All right, you can go ahead now. I just sent it. Yeah, so we did question 1, so go to number 2.
Would I draw 2 trees for this, or we're picking one ball from each bag each time?
All right, so good. So notice, read what it said. All the outcomes. So all the outcomes on one tree diagram. So what is going to be happening? It says a ball is drawn at random from each bag. So you can start with whichever bag you want, but you need to just show the tree diagram for both bags together on one. Good, now go back B now. So you can get a red from bag A, then draw your 2 trees from both there, yeah. No, no, not going as separate. It's still one tree diagram. We're saying that now that you get from A, draw 2 branches from red and 2 branches from green. Yeah, exactly. The second branch would represent now the draw from bag B, and you can do it now. Very good. Part 1. Very good. Green intersect red plus red intersect green. At least one ball is red. What does at least mean?
Means that it can be red, 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 green, or green, red.
Very good. Or I wanted to hear you say it could be this, then it could be one minus the probability of no red.
Oh,
Isn't
is it?
that so as well? Yeah. Yeah. Very good. 7/15. Nice. All right. One more tree diagram is there. Next page. Yeah, man. Tree diagram is correct. So now we need to work out So it said find the probability you get hit twice. Why do you have hit, hit, hit? I don't understand why you have hit, hit, hit. Good. Very good. Very good. That's correct. Nice. All right. Nice, nice, nice. All right. So how did you find tree diagram now?
This one is easy.
All right. This one is easy. Nice. I like that. Good, good, good. All right. So that means we didn't get to look at normal distribution, but we will cover normal distribution on Thursday, and we will also cover combination. So we'll finish combination and normal distribution, then that will finish up statistics. And so if you want, we could do a statistics, we could do a module 2 test this Saturday, or maybe we could start module 3 and then the next week, you get some time to study over module 2. You get the module 2 practice test next week, right? All right, Jamie. So take care, and I will see you on Thursday. Enjoy the rest of your weekend, all right?
All right, you too soon.
All right, take care.